The graph of the function f of x is given to the right. On a separate sheet of graph paper, sketch the following. So I'm just going to talk about these really quick. In the first part, we have the function, then add 1. That is a vertical translation up 1 unit. So I'm going to do that in a second. Just want to talk about these. Number 2, f of x plus 1, we're actually adding 1 to the input, which will be a horizontal translation, left 1 unit. Number 3, the opposite of f of x. So we are multiplying the function by -1, an invisible 1 out here, so -1 times the function will be a reflection over the x-axis. F of the opposite of x, or -x, we're multiplying the input by -1, which will be a reflection over the y-axis. And last, number 5, 2 times f of x. We're going to double all the outputs, which will correlate to a vertical stretch, as we will see. So what we need to do here, first I'll take the first one, f of x plus 1, and I'll zoom in a bit. So if this is the graph of some function and I'm translating it up 1 unit, literally I'm just taking the entire graph and bumping it up 1. So I purposely gave you some points as reference to move up. For instance, this is the ordered pair -4, -2. If we shift it up 1, it's not going to move horizontally at all, just up 1 unit. So -4 now outputs -1. Likewise, -2 now outputs -1. 0, 1, up 1 unit, now 0, 2. 3, 1 becomes 3, 2. And 4, 0 becomes 4, 1. And connect it as smoothly as possible to build a congruent looking graph. There we go. Simple as that. Adding 1 to a function translates the graph up 1, or shifts up the graph 1 unit. Our second function was f of x plus 1, adding 1 to the input. That's going to correlate with a horizontal translation, so I need to actually add another little ordered pair in here, -5, because this ordered pair now, -4, -2, is going to shift 1 unit to the left. -5, -2. The ordered pair -2, -2 shifts 1 unit to the left. Now -3, -2, and that's going to be the new horizontal segment. Okay, you can literally see it move it over. 0, 1 translates to -1, 1. We'll connect that. 3, 0 translates to 2, 0. Connect that this time. And 4, 0 translates to 3, 0. Connect it. There we go. So still wind up with a congruent looking graph. Translations do that. Just remember, adding or subtracting is a horizontal effect to a function. Adding or subtraction to a function is a vertical effect. Adding or subtracting to an input has a horizontal effect. Number 3, negative f of x. Go back to this. Alright, so all our outputs are now their opposites. Or, I mean, what we're going to end up with is a graph that is reflected over the x-axis, but how that even comes, where that comes from is, again, this is the ordered pair -4, -2. Take the opposite of the output. Well, -4 now outputs +2. And you can see the reflection. -2, -2 now outputs +2. So here's that horizontal piece reflected up. Here's the ordered pair 1, 0. 0, 1. Well, now it's 0, -1. Opposite the output. And we have the ordered pair 3, 1. Now becomes 3, -1. And 4, 0. No opposite of 0, stays right there. So doesn't look completely straight there. That's a little better. Alright, and that's a sketch of the graph, the opposite of f of x. Let's look at f of negative x, or the opposite of x. So now we take the input values and find their opposites. So input -4, output -2 on this function. Well, now take the opposite. 4 outputs -2. There we go. -2, 2. Opposite of the input, 2, -2. 0, 1. Opposite of the input, still 0. Keep the output. 3, 0. Now becomes -3. I'm sorry, 3, 1. Now becomes -3, 1. And last, 4, 0. Now becomes -4, 0. Connect these as follows. And there we go. Again, writing on the tablet isn't as easy as graph paper with a pencil, but hopefully this helps. And the last function, 2 times f of x. I'll use orange for this. 2 times f of x. So we're just doubling the outputs, which will correlate to a vertical stretch. -4, -2 now becomes double the output. -4, -4. -2, -2 now becomes -2, -4. 0, 1, double the output. 0, 2, twice the outputs. 3, 1 becomes 3, 2. And 4, 0 still remains 4, 0. We connect this as carefully as possible. And that's it. So know your transformations. Know how to sketch them given a graph. Given in function notation, know how to generate any of those graphs. Number 8. Move on to number 8 now. Okay. So using the function, the square root parent function, write a function that translates g of x 3 units to the right. Well, that's simple enough. So if I'm translating 3 to the right, I'm going to ask me to call this function h of x. Oops. Let's fix that up a little bit here. 3 units to the right. That's a horizontal effect, so I replace x -3, and that's it. Part 2, write a function j of x that reflects h of x over the y-axis. So given the verbal, this is just like the previous problem, except you are just given words here. You need to write the notation. Write a function that reflects over the y-axis. Then I have to reflect h of x over the y-axis. So what would I need to do to reflect this? I would need to replace the input with its opposite. So this x gets replaced with a -x, and then we bring down this -3 that was there before. So write a function j of x that reflects h of x over the y-axis. And sketch a graph of the 3 functions all in the coordinate plane. Use a separate sheet of graph paper. Well, I cannot pull up decent looking graph paper, so I'm gonna have to just deal with a sketch as best I can. I'll label this x and y. So g of x was the parent function, square root of x, so 0, 0, 1, the square root of 1 is 1, 2, 3, 4, the square root of 4 is 2. And make that look like the shape it's supposed to look like. That, so this will be g of x. on the same coordinate plane, graph h of x. So 3 to the right. Well, just like before, we take this ordered pair. 0, 0, 3 to the right is now 3, 0. 1, 1, 3 to the right, 1, 2, 3 is now 4, 1. And unfortunately, this last guy is probably not going to fit on for me, but 4, 2, 3 to the right, probably just make it, would be 7, 2. So, as best I can there, I'll call this the point, 7, 2. Again, you use graph paper to look a lot better than this. And this should be h of x. And now, last function, j of x translates h of x, reflects h of x over the y-axis. So this point is 1, 2, 3 away, so we'll come 1, 2, 3 away here. And now we are 1, 2, 3, 4. This is now 5, 2.